Okay, 27. The Trial Urban District Assessment, a government study for student achievement in large urban school districts, gives a reading test scored from 0 to 500. 243 is a basic reading level, 281 is proficient. Scores from a random sample of 1470 had X bar is 240, standard error is 1.1. We don't have the individual scores, so I don't know what the population looks like, but I can use the T procedures. Why? Well, what are the conditions? Okay, one, simple random sample, that was given. Two, we can assume the data is independent of each other, that each kid was taken independently of each other, and that really comes from the fact that it's a simple random sample. And thirdly, N is large. N is large. Because N is large, we have that thing that we talked about a while ago called the central limit theorem that assures that the sample distribution is approximately normal. And the sample distribution is what allows us to make this and make claims about X bar and do confidence intervals and hypothesis tests and everything. Okay, so B. Give a 99% confidence interval for the mean score of all Atlanta 8th graders. Okay, so that'd be X bar plus or minus T star S over square root of N. Well, X bar was given as 1470 and plus or minus T star. We got to figure out what T star is for 99% with a big sample. And then what's S over square root of N? Well, they gave us the standard error. Okay, the standard error, standard deviation is S. Standard error is S over the square root of N. Okay, so we got to figure out what T star is, and the standard error is 1.1. So they actually gave us that. So now if you look at your T table, we got to figure out what T star is. Well, what are we going to use for T star for 1470? That's a really large sample, and the larger the sample is, the closer our curve is going to be being a normal looking curve. So 1470, if we look at, we've got in our table for 99%, was it? Yeah. Look over at 99%. If the degrees of freedom is 1,000, that's going to be a little more conservative. The next one up is our normal distribution. So let's go with the 2.581. When we do it on our calculator will actually calculate it a little more accurate than that. But we'll go with the next one below it, which is 1,000, since I don't have 1469 on there. We will do that. Oh, and I actually can't do this on the calculator because I don't know individual S or N, so I actually just have to do this by hand and calculate 1470 minus 2.581 times 1.1 and 1470 plus 2.581 times 1.1. So let's go ahead and do that. And I get 1470 minus 2.581 times 1.1. I get 1467.2, and let's see. Oh, whoops! What am I doing? Not 14. Oh my goodness, you guys! I'm sorry. I put in 1470. You guys are probably going crazy there, aren't you? And I make mistakes too. Obviously, right? What's X bar? It's not 14 something. I'm going, these numbers are huge. X bar is 240. You're probably watching this going, Jim, what are you doing? What are you doing? What are you doing? It's 240 is X bar. 240, I apologize. So, let's see if I get that rid of that. So it's 240. Yeah, and I don't want to go back and redo the whole video, so I'm going to leave it at that. So 240 minus 2.581 times 1.1 is 237.2, and 240 plus 2.581 times 1.1 is 242.8. So there's our confidence interval. Okay. All right, C. Urban children often perform below the basic level. Is there good evidence that the mean for all Atlanta children is less than the basic level? Well, this says this. I'm 99% confident the mean score is between 237.2 and 242.8. And so the question is, what's the basic level? Well, the basic level is 243. Well, I'm 99% confident the average score is below 243, right? So what do you say for C? Is there good evidence? Yeah, this looks like it's pretty good evidence. Okay. Yes, because of that statement right there. Because the mean, I have evidence that the mean lies in this interval. Okay.